Right, for the unit on geometry, again, the list of items that you need to be able to do. First of all, you do not need to write down the formulas for the different shapes, whether it's finding a perimeter or area of two-dimensional, or the volume or surface area of objects. All right, so that formula sheet will be given to you. However, you might need some other information that you can obviously write down in this unit. So the first thing that you need to be able to do is composite shapes, both their perimeter and area. So again, this is something you did in grade 9, not too bad. So for instance, if I have a shape that looks like this, and I ask you to find the perimeter, in most cases, the perimeter is not going to include the middle part. So you could see that I'd want part of this, this, but not the top part of a rectangle. And I would want half of a circle's circumference. Okay, so just be very cautious of what shapes are involved. The same has to do with area. Just make sure that you identify the shapes and use your formulas. The other thing that's important here has to do with composite objects. So in other words, finding the volume of something as well as the surface area. Again, taking your formulas, either adding things together or subtracting things. Now, really what's different here has to do with the optimization. So I'm going to take a look at the first thing. Optimization, and there's a star there because this is really what is new in grade 12. It's really important when they're talking about optimization is they're talking about something that has a minimum perimeter but a maximum area. Okay, so especially if we're talking about two-dimensional shapes. So the first thing is for us to recognize that a circle is actually the best shape that optimizes. Okay, it will give you the minimum perimeter for the maximum area. But the reason we don't spend a lot of time on it is because it's not practical for most questions. Okay, we're not going to make a circle fence. Okay, it's not practical in other ways. Okay, so then we look at a rectangle. So for a rectangle, a square optimizes the area as well as minimizes the perimeter. So I can get away with less fencing and I can create the most area. So that's what that's all about. Now, the other thing that was interesting in this unit had to do with restrictions. So sometimes they said the numbers had to be whole numbers or had to add up to a certain number. So what we have to do here is usually, in almost all cases, it is the number that's the closest. So the numbers that are closest. So in other words, they're closest to being a square. So if I have the choice between something that's 4 by 5 compared to something that was, sorry, let's choose a different one, 3 by 8 or a 4 by 6, which numbers are closest together? Well, between a 4 and a 6 is a 2, right? And between a 3 and an 8 it's a 5. So in most cases that would be the best if I was looking at those numbers because they're closer together than the 3 and 8. Okay, so the next thing has to do with three-dimensional. Now, three-dimensional is not dealing with perimeter or area. It's dealing with surface area and volume. Okay, so to optimize, we want to reduce the amount of surface area at the same time getting the most volume out of it. Okay, so again, in this case, a sphere is the best for optimizing the volume with the minimum surface area. But again, it's not practical. So if I'm making an ice cream carton, obviously I want to fit a certain amount of volume into it, but I want to reduce the amount of packaging that's going to be required. Obviously, I'm not going to make it out of a sphere. Why? Because it wouldn't set on the shelf very well. Okay, so what we're looking at is usually the next best thing is a cube. Okay, so the next best thing is a cube. So when we're looking at a cube, remember the volume of a cube is going to be s cubed. Okay, so that's important. And sometimes they will tell us what the volume is, and so we could figure out what the side is then from that. So if I tell you the volume is, let's say the volume is 64. Again, I'm just making that up. What side length do I want to create minimum surface area? So I would take 64 equals s cubed. Take the third root of both of those, and I'm just going to move this down just a tiny bit. So if I take the cubed root of both, and I forgot my equal sign in there, the cubed root of both, so 64 to the 1/3 would equal s. And again, you could actually take your calculator and actually calculate that. Turn it on, get out of that screen. So I would go 64 to the power of 1/3. And amazingly, it's 4. And yes, I knew it was going to be 4. So I would have a cube with a side length of 4 is what I would want in a question like that. Okay, now we did quite a few questions, so make sure that you look at some of those. And the last thing too that is a possibility is the next shape would be a cylinder. And a cylinder, what we want is a shape that has the diameter and height are the closest in the measurement. Okay, that will create optimization. So it's almost like taking, so if we're looking at that as being, it's not what I wanted, but that's all right. Okay, so I'm going to make the black one have the same diameter. If I take it and turn it around, so actually this would then create, this would actually create then a cylinder that would be optimized because the diameter and the height are the same. All right, so in other words, it's almost making it like a cube where all the sides are equal, but again, it's in a circular kind of motion. Okay, so make sure you look over your test, especially the optimization questions. And again, if you have any difficulty, either rewatch the video for that unit or ask for some assistance.